Hello everyone, this is Ari from Pantech. So in the previous session, we have came to the core concept of DAC, which is a digital to analog converter, which will convert a digital values into an analog value. So this is a concept where we will use in the media. We can see the concepts in this media players. So the DAC is a important component for the playing the audio. So it is going to convert the digital DAC is going to convert the digital values into analog values, and the analog values is going to get into the amplifier. Then it is going to get out of the it is going to get into the speaker, and the sound is going to get out of the speaker. Okay, so this is how the media players will be working. So in yesterday's class, we have developed the code for analyzing the waveform, right? So today, what we are going to do is we will debug those code which is developed yesterday, and we will see the output in the digital oscilloscope, and we are going to create a sine wave. So that is what we are going to. So before getting into the next topic, now you can convert this masterclass into an internship, guys. So it is in a 1 month internship on embedded systems. So we are already learning the STM32, which is based on ARM Cortex M4 in a register level, right? So we are learning like in a register level. So it will be a very much useful for you. So you can you have to when you have to improve yourself, you have to practice on these things. So while practicing, you need some internship like a reference, like what are the ins, what are the bugs, all things you have to need some reference, right? So for that purpose, this internship is provided. And in what is the benefit of this internship is lots of topics you can refer to this internship, and lots of things going to be added in this internship, like CAN, LINs, lots of communications and tax core concepts all coming on the pipeline of courses. So don't miss this opportunity. Our fees is 1,200. So our discount price is 599. Okay. So you can use this ESMC1 coupon code, and by using this, you have to pay only 691 only. So by paying this fees, you can register for the internship and you can get more benefits. Okay. So now we will get into what are the benefits you will get. So as I said, so we are practicing lots of codes, right? So we are practicing lots of codes in the live session, and you are developing lots of core concepts. So you have to practice yourself for making to upskill yourself, right? So when you are practicing, you will come with some errors, or you will have some doubts related to those things, or you will after executing the code, you will not get output like this. So for that purpose, you can refer to these 30 days videos. So what is the best benefit is the 30 days of masterclass live sessions will be available as a recordings in this internship. So and lots of topics also going to be added to those videos. So it will be accessible for those recordings will be accessible for 90 days. So you can use those videos as a reference for hands-on practice and developing a code. And even the concept is you are not clear with the concept means you can again rewatch it. So the concept will be get clear. Okay. So and what is the next benefit? So next benefit is we are going to do lots of hands-on practice on embedded projects, and you are going to implement what is the project I have teached you, and you are going to implement those in real time by yourself. So while developing the project, you will get lots of errors and lots of bugs. So you can in this internship we will provide a lots of practice on embedded projects, and you can ask the questions to clear the doubts to myself as a me. Okay. And what is the next benefit? So next benefit is you will get a 30 days of download presentations. So I'm giving a presentation, right, for 30 days. So you will get this. Plus additionally, what you will get is what are the things we are using. We are using data manual, reference manual, programming manual, user manual, lots of things. So those are all the things what are we are using to develop the code, and all the things we use to learn the code concepts and communication protocols. All those files also will be included in these 30 days of downloadable presentations. So you will get the presentations as well as what are the things we are using for developing the code and the projects. And also in addition, you are going to get a codes that I am developing. So I have developing a code in live sessions, right? So those codes are going to be .c files. It will be shared you as in a format of .c file. So you can refer to those codes also. So it will be exclusively available for these internship students. So you can you can get those codes also. So you can use those codes for reference also. Okay. And What is the next benefits? Is we will have a one-to-one live sessions. So what is this? Is you can interact with me for 1 hour every Saturday class. So you can ask the doubts. You can clear the topics doubts related to the topic which I have taken from the day 0 to till the date, or even you can ask the doubts related to the embedded systems out of the topics which I have. Now I am taking STM32, right? If you have a doubts related to the other microcontrollers, or you are doing lots of other, or you are involved in other embedded projects, you have a doubt related to those projects, or you have doubt related to this other microcontroller, means you can also use those mastermind class to sessions to ask the questions related to the out of the session also. So you can ask the doubts related to the embedded systems out of this STM32 also. So you can use this mental life as these opportunities. So this is about how you are using your this opportunity, how you will make use of it. So you can also you can ask me to, you can also prefer me to do and take some new topics some topics, you some core concepts you like to be learned, right? You would be want to learn those concepts. So you can say it in my Saturday class to me directly, so I can prepare on those topics, and I will be giving a presentation in this internship. So it will be very much exclusive for the internship students only. Okay, so those even out of the topic, not based on STM, if you can ask, if you want other topic more than out of this team, is you can also ask me that. So you can prefer me that. So I will take this. I will get into the topic and implement those things, and I will be giving you a recorder session for you, and also I will give a code on developing those things and if for while implementing in a real time. So these are the benefits you can get by this internship. So this is about how you are using this opportunity. Okay. So next is after registering, you will get an internship confirmation letter. So after registering, you will get a confirmation letter, and two, you are going to get a 2 e-certificates. What is this benefit? So you can use this certificates in the resumes. So what is the benefits? Is we are learning STM32 based on ARM M4, which is a industrial based controller in a register level, right? We are not using a advanced library, all libraries, or some things which will be very much easy like Arduino programming. So we are getting into a register level. So it is in a from zero to ground. We are starting from ground to advanced, right? So this is a basic step. So we have to know about registers to develop the all GPU like drivers. So we are learning STM32 in register level. So this certificate will be very much useful for you. So what are the two certificates we are going to give? We are going to give two certificates. One is for participation and another one is for course completion on this STM32 register level. Okay. So it will be very much useful to you. So the internship fees is 1,200. So don't be afraid. So you don't have to pay this full amount. You can use this ESMC one coupon code so that you can get this 509 discount. And the discount fees is 691 only. Okay. So you can get the internship at 691 only. So this is the registration link, guys. This registration link will be available in the chat box. You can see this, and or you can see this description box. In the description box, this registration link will be available. So join as internship user and use this internship as a upskilling opportunity for you. Okay. So we will get into the concept. We are going to see this. So the Pantech e-learning is offering a 100% placement for your students who was trying to get into the embedded engineering domain or Python domain, Java's data science domain, artificial engineers, and electric vehicle engineering. So these are the domains we are focusing on. The Pantech e-learning is focusing on these domains and providing a 100% placement for these domain-based industries and companies. So guys, you can enroll for this. This link and link will be provided in the description box and as well as chat box. Or you can also use this QR to scan and enroll. So you can join our team. Want to make a career as an whatever domain you needed. So what is the thing we are going to do here is we are analyzing the industries around us. So we are seeing what are the technologies they are asking from the students. What is the technology they have the industry required. So what is the technology that the industry needed. So we are analyzing those things, and as per the industrial requirements, we are training the students, and we are teaching them how to attend the interview and all the things, and we are giving them a 100% placement on based on the domain core industry. So if you take embedded, you will take a scenario of embedded engineer. So you will get a placed in the embedded domain. So the training is going to be based on the what is the as per the industry's requirements. So what are the technologies they are asking from the students? So those technologies going to be teacher you going to be get teacher going to train you for the this course for up to 3 to 6 months, and we are going to give you offer you we are going to make you placed in this your dream companies. Okay, so guys, don't miss this opportunity. So you can enroll this. So enroll as soon as to get this. Lots of offers are going on. So you can enroll who's getting first will get the best offer. So register this and get a best offer and get placed in your dream company. Okay. Now we will get into the code which we have developed yesterday, and we will debug those codes. Okay. So this is a code which we have developed yesterday. So for generating a sine wave, we are going to order this code. So we will first see this output. Okay. First we will upload this and go to the debug. So I have already added the So I have already added this variable which is value. So this value is going to be the my voltage. So my voltage is going to increment. Okay, till it reaches the 3 volt. Okay, then what is the value we are going to send into the this set value DAC1 data register 12 bit. Okay, which is right aligned. So now we will compile this code. Okay. So you can see now our values are getting changed. So right, you can see it right. So from 0.2, it is going to increase the voltage. So this is what we are going to see in this digital oscilloscope. So we are going to see the waveform which is increasing in the time period of 2 seconds. Okay. So you can see we have a debug value here. So we are getting, if my voltage is 3.2 means my digital value will be 2739. Okay. So this is how it will work. So now we will get into the. So I have a digital oscilloscope. Okay. So now you can see my voltage is changed from 0.6 to 2 volt. Okay. So now we will wait for 2 seconds, and you can see our voltage is now changed to next voltage. So after reaching the 3.3 volt, 3 volt, it is going to again come to the starting position, which is 0.6 volt. So you can see now it is again came to the 0.6 volt. So this is how we will generate the waveform. So this is how we will give the input to the amplifier or a speaker also. So this alternating waveform is creating the sound with the medium of using the speaker. So this is how the media files are working. Okay. So now we are going to get into the next console. Okay. So what is the next thing we are going to do is we are going to develop the code for sine wave. So what are the things we have to do? So first thing we have to add this math.h for this sine calculation. Okay. So we have to add this header file for the sine calculation because it will have the inbuilt sine function. Okay. So what I'm going to first declare int of I. Okay. So what is the next thing I'm going to create is I'm going to create a array. So it's going to store my values of sine wave. So it is in the int of 32. Okay. Unsigned int of 32. In this I'm going to create it as a sine value. Okay. Sine value. So I'm going to give this size of 100. Okay, and I make it as 0. Okay. Next, what is the next thing we have to do is we have to define the pi value because we are creating a sine wave, right? So we need the pi value. So I will first pay. What is our pi value is 3.1415 and 926. So this is our pi value. Okay. So what is the next thing we are going to do is we are going to Now we have to set the timer. So as per the timer only, it is going to react. So we are going to use this trigger function. So as per the timer is going to send a trigger function to it, update event. So as per the event is updated, there is going to be a trigger generated in this DAC. Then it will reach the data as per this trigger. Okay, as per our sample. So what is the next thing I'm going to create is we have already created this. Wait. So what are the things we have to create? So what I'm going to now create is I'm going to create a function for time. So I will configure this timer too. Okay. So only thing we have to create is timer function. Okay. So we will get into the timer function. Then we will alter some alter our DAC functions. Okay. So what is the first thing we have to do is we will get into the. So we have these timers. So we are going to use this timer 2. So this is registers for timer 2 to timer 5. So what is the first thing I have to do is I have to enable this clock for this. So go to the RCC registers. So go to the we have it the timer 2 is in the ABB 1 bus, right? So you will see it. So you can see we have the timer 2 in this 0th bit. So we have to send this logic 1 to this 0. So RCC of ABB of is equal to 1 left shift of 0. So what is the next thing we are going to do is we are going to set the prescale value. So the prescale register is timer 2 PSC will be the prescale register. So what is the value I'm going to do is I'm going to generate a 10,000 hertz per cycle. That means what does it says? That means we are going to generate a 10,000 hertz. So 1 hertz will be equal to the 1 microsecond. So we will do this. We are going to divide this prescale value. How we will get this prescale value? We are going to divide our clock system clock frequency divided ABB 1 bus frequency divided by what is the hertz we need. So we are needed is 1 hertz, which is equal to 1 microsecond. So now I have to divide the 16 megahertz of frequency by 1 megahertz of frequency. Then I will get this 16 value. Then I have to minus 1 to give the value to the prescale. So what next thing we are going to do is we will configure this timer to control register and we will reset this register. Okay, so CR off on. So I am going to reset this register first. So what is the next thing I am going to do is I am going to set this auto reload value. Okay, so I am going to set it in auto reload value. So it is going to be 100 minus 1. So this is going to create me a sine. So what is the next thing we are going to do is we will get into the timer registers. So in this go to the so we have a slave mode control register. In this we have to select this external trigger prescaler. So which will be in this you can see it. So it should be available in this 12 and 13th bit. So we have to enable this prescaler. So what I am going to do is I am going to divide this frequency, the external trigger frequency by 2. So I am going to send this logic 1 to this 12th bit. So I will send this. So this is a prescale value. So this is going to set the prescale value for the external trigger. So as per this frequency, the trigger is going to act. Okay. So in timer 2, in SMCR, I am going to set 0 cross of 1, left shift of 12th bit, right? So 12th bit. So now we have external, we have set the prescale value for this external trigger. So what is the next thing you have to do is you will get into the timer 2 control register. So in this you can see you have to set this master mode selection. So we have to give this update event. So for update event, I have to set the logic one in this. In which bit I have to set it? So for update event, it is 1, 2. Okay. So I have to left shift this 2 to this 4. Always I have to left shift the logic 1 to fifth bit. So this will set my update event. Okay. So what I'm going to do is in timer 2, I'm going to configure this control register 2, right? So CR of 2. In this, I'm going to send the logic 2 to the fourth bit. So this will enable my update event. So what is the next thing I have to do is we will get into the. So what is the next thing we have to do? We have to get into the slave mode control register. In this we have to see is 7th bit. So MSM bit, which is a master slave mode selection. So we have to send logic 0 to this bit. So we are not going to use this. We are going to not select this timer as a master or slave. Okay. So what is the next thing I'm going to do? Timer of 2 in this. I have to left this 1 to the 7th bit. So this is going to disable my master and slave. Okay. So what is the next thing? Final step we have to do? We have to enable the counter. So in this timer 2 of control register 1. So it will be in this control register 1, CR of 1. So I'm going to 1 left shift of 0. Okay. So now I have enabled this counter. So now we have finished this. So now we have finished the setup for timer. So what next we are going to do is we will get into the GPS as the same as the function. Next we will get into the set value also will be the same. Okay, we will make this as a static. Okay, to so what is the next thing we are going to do is we are going to alter this DAC function. Okay, so we have already enabled this clock. Then we have resetted the control register, right? So what are the extra things we have to add here is go to the DAC registers. In DAC, you have to go to the control register. In this, what are the things we are going to use is we are going to enable this channel 1 trigger enable, and we are going to set this which channel trigger selection. We have to select this time, which timer is going to give the update event. Okay. So which is the timer we are using is timer 2, right? So I have to left shift this logic. What is this? 1, 2, 4. So I have to left shift this logic 4 to this third bit, and I have to left shift the logic 1 to this second bit. So these two things we will do DAC of in DAC 1 in control register. I am going to on left shift of 2. So this will enable my trigger function. Then I have to select this trigger event. So DAC of 1, CR of 4. So this is going to select the timer 2 as a update event to this third bit, right? So we will check it. Yes, this third. Okay. Now we have finished this DAC configuration also. So what is the left? What is the next thing we have to do? We will take these all the values. So okay. So now we have to add this timer function here first. So timer of 2. Now we have added this function. So what is the next thing we have to do is we will have a formula for developing a sine wave. Okay. So I have already created this sine array. So I am going to create a for of I is equal to 0. I is greater than. So it is going to this loop is going to run till this condition. Okay. So I of plus plus. So what is the thing I have to do is Now I will store the values in this sine value. Now I will by indexing. Okay. So what is the formula for generating a sine wave? So we have a formula which we have to call this sine function. Sine. In this we are going to increment this I. So I into 2 multiplied by, which is a pi value we have already defined in this header. So you can see this we have already defined here. So we have already defined this pi value. So divided by 100. Then we are going to plus it with 1 and multiply it with, what is our resolution will be? It will be 4095 divided by. So this is the formula to generate this sine. Okay. So what is the next thing we have to do is we have to send this sine values to the data register of the DAC, right? So we will send these values. So we have already created this where is this set value. So we have already created this set value. So we are going to give the data to in this set value. So for that I am going to create a set value in this sine value. So I am going to increment by the index. Okay. So this is going to create a sine wave for me. Okay. So I think we have done all the configurations. So we will make this production shows. We will make it as J. Okay. Now we will compile this and so what we are going to do is next we will upload this code into our board and we will see the output. Okay. The code is uploaded. Now we will get into the debug. So these values are removed. So we will remove these values. So what are the values we have to see is we will see this sine value. Then we will see these values. Then we are going to see this DAC data register is getting the data or not. So in which register we have sent the value? We are sending it in that 12-bit right align, right? So we have to check these only. So now we will run this. Okay. So you can see our data are changing in this register. So data register of 12-bit right align. So you can wait. Static and the way it is not wait. We will enter this expression. Okay. So this is how we will send the data to the site. So now we will see the output in this digital oscilloscope. Okay. So we will get into this digital oscilloscope. So our sine wave is already generating it. Right. I will connect this to the EF4. So you can see our sine wave is already generating. Okay. So we will the 10 node. So we have to add some delay here. Okay. So you can see as per the delay, the sine wave is been changing. Okay. So when I give those 20 milliseconds of delay, so I can get this exact sine wave. So I will increase this delay. So by increasing this delay, you can see this. So this is how we will create the sine wave, and this is how the DAC is sending the data to the speaker, and by varying this voltage only, the speaker is generating the sound. Okay. Now we have created this sine wave. Okay. So what is the next thing we are going to do is, so we are going to convert this. I have already converted this audio file. Some of 1 minute, it is 2 seconds of audio length. So I have converted it into a digital file already. So what I'm going to do is I'm going to send those digital values in this PA of 4 pin, which is a DAC output. So this DAC output is going to get into the speaker, and so we will before getting into the speaker, we will see how the waves works in this digital oscilloscope. Okay. So what are the things you are going to do is right. So I will add this. I will send this digital values, audio digital values in this downloadables, guys. So which will be available exclusively for this students, for internship students. Okay. Again, I will make a copy of those digital values, which is going to be sent into a data register of that, and it is going to convert those digital values into a analog values. Okay. So I'll copy those values and paste it here. So these are the digital values which we are going to play to the speaker. So we are going to use this DAC to convert it. So we have to do some changes before doing this. So what are the changes? So we will see it now. So everything will be same. Just we have to change this timer prescaler and auto reload value. So how to determine these values? Okay. So before that, what we have to do is we have to change these. These are in a 32-bit, or digital value is in 8-bit format. Okay. So I'm going to change these things into 8-bit. Now we have changed those values. Now I will remove these. Wait. So this is a variable. This is the array where my digital values are stored. Okay. So I'm going to increment those things. So what is the total values in the what is the total number of values in this digital array? So it is 65,468. Okay. So we are going to read till this. We are going to run this loop till those getting to the value. Okay. So 65468. So it is going to this for loop is going to run till this value. So it is going to send this value to the data register from this starting index from 0 to 65468. Okay. So this is the thing we have to we are going to send this values here. Before that, we have to change change the timer configuration. So what is our prescale values? Wait. So you can see here our timer frequencies for this audio is 22,050. So to derive this auto reload value, we have to use this formula. So you can see our clock frequency is 16 megahertz, right? So wait, I can. So it is clock frequency is 16 megahertz, and we have to find this auto reload value. So what is the prescale value I'm going to set is? It is 99. So 99 plus 1, it is going to be 100. Okay. So it will as per this formula, and we will finally get this auto readout plus 1 is equal to 725 divided by 100. So this 100 is our prescale value, and this is our value derived from this these values. Then this one will come to right side, so then minus 1. So the value 725 divided by 100, the value we will get is 7. So 7 minus 1 is 6. So finally we are going to use these values. So we are going to give the prescale value as 99, 100 minus 1, and we are going to give this ordinary value as 7 minus 1. Okay, so we will set these things. So what is our prescale value? 100 minus 1, and this is 7 minus 1. So this is the changes. So this is changes is made as per the audio file. Okay. So now we will compile this, and we will run these programs. Okay. So before that, we will check these codes. Okay. So now we will upload this code, and we will see this output. Okay. So what is the one thing we have forgot to do this? So what is our size of our data we are sending? It is 8-bit format, right? So where we have to send this data in DAC? So we have to send it in this 8-bit data register, not in 12-bit data register. Okay. So in this we will have an 8-bit of R1. So in this register only we have to send these values. So we will file this and upload. We will remove these values, and we are going to add these. Okay. Now you can see our values are already stored in this array. So you can see, wait, I will show it. So you can see our first value is 126. So which is loaded in this 0th index. Likewise, it is loaded till this 65468. Okay. So we will see this output. So what is this loop is going to do is it is going to call those values inside this, and it is going to send the values to this 8-bit R1 in this register. Okay. So now we will compare this. So you can see now our data is getting sent into a data register of 8-bit in this right line. Okay. So this is how it will send the data. So what is the next thing we are going to do is we will see the output in this oscilloscope. Okay. Digital oscilloscope. So go to the digital oscilloscope. I think we are getting the readings, but we have to change the time. Okay. So you can see our waveform is changing. So wait, I will increase some. This is so. This is a so you can see how these data are sent into the speaker. So this is how the speaker or amplifier will get the data from the DAC. So it will be the speaker's sound is a form of varying voltage. So the varying voltage is producing the sound. So this is how the media players are working, and how this the songs audio files are converted into a sound. So guys, today we have already developed the code for DAC to change the voltages, and we have seen this sine wave, and we have created this some digital audio. So what is this audio? Wait, I will show it. So this is the audio. So this is the audio I have converted. So this is the audio which I have converted into a digital format. So this is the audio's digital format. You can see it here, right? So we have values of 0 to 65468. Okay. So now we have seen the sine wave configuration, and we have seen this how to implement this digital values into a DAC, and to send this media output. So the today class is over, guys. So thank you for today's session. We will meet on next session with a different topic. Okay. So thank you, guys.